All right, look up. Okay, we're looking at the pink packet now. We're looking at the first problem in the pink packet. I think we had just like barely got started talking about this last time, so we'll just kind of start over. No one talked. Okay, the goal is to find, listen, the goal is to find area R. Like so. Quick family story. So I have 5 kids. My youngest is now will be 22, 25 this summer. But when he was like in 4th grade, his older sister was like your age. She's sitting at our kitchen table. She's working on a problem very similar. And she's just asking me for a little bit of help. And my son, who's like in 4th grade, hears us talking about finding area. And as good, bright-minded 4th graders will do, he's like, yeah, I can help. I learned how to find area in class today. I'm like, oh, cool, Derek. Show us how to do it. And he's like, so he really, like, he takes it, he gets on a piece of paper, and he draws, like, grids, right? And he's like, it's easy. You just draw the shape on the grid, and then you just count the squares, and that's how you find the area. Good job, that's awesome, you know, that's what he learned. I said, well, here's your sister's problem. Her name is Jamie. She's got to find the area of this shape like this. He looks at it, it's like it's not square, right? He's like pondering, you know. And so Derek, how would you find this area? And he just looks at us and goes, you don't. So there you go. Class dismissed. Okay.
Absolutely. Back.
No debate.
It's on the couch. The area. No.
Find the area of R can't be done.
Okay. How we actually find area R is we are first going to find, now I wouldn't write anything for a minute. Like just make sense of the idea. Once you make sense of the idea, the writing becomes rather easy on this problem. Because this is calculator aloud, there's not a whole lot to write down. It's just understanding is the key. So, I'm going to clear this off. We're going to start by finding this area here. We're going to follow this curve until region R switches from using this function, and region R will start using this function. So we're going to follow the curve to that point. We're not going to do anything with the green for a minute. We're going to focus on the purple. So instead of finding area R, we're going to start by finding the purple area. Once we've found the purple area, we will then find the green area. Do you have questions about that? The reason I'm finding 2 different areas is because in the purple space, the area is defined by the purple equation. In the green space, the area is defined by the green equation because of how the region is shaped. Give me a 1 to 5 as to how comfortable we are with that basic idea that to find region R, I really need to pay attention to the purple equation for all of this space. But then I need to pay attention to the green equation for the green space. Give me 1 to 5. Show me. Checking everybody. Most people feeling good. Got a couple that are not really understanding why I did that. The reason I did it is I'm going to find the area of the purple space by creating rectangles that will fill the purple space. So not being very good at drawing rectangles, I'm going to use a spreadsheet to help us. Okay, so this orange line is exactly the same thing as this purple line here. So in this spreadsheet drawing, this orange graph is this purple graph. And what I did is I created rectangles that fit underneath that purple graph. I'm going to find the area of each rectangle and add them up. And that will give me the area of the purple space. And the reason it's only using the purple equation is because in the purple space, the top of every rectangle is touching that purple equation. It's not touching the green equation. Okay, so back to here. Show me again, 1 to 5, if you're understanding why I'm splitting region R into two separate spaces. The purple space where the top of every rectangle in the purple space is going to touch the purple equation. The bottom of every rectangle in the purple space, ignore the bottom, sorry. The top of every rectangle in the green space touches the green equation. So I have to use the two equations separately because of how the rectangles fit in the space. So 1 to 5, if you're comfortable, I'm splitting it into purple and green. Show me. Be honest. Question for Jacob in a second. Wait, Jacob, question.
No, this is supposed to be the 5.
Haley, I'm still not helping you very much.
I don't know, I just don't get it.
That's okay, let's keep going. It'll click. Let's keep going. 2 points for Haley. Okay, so here's how it works. So look at this spreadsheet. Give me 1 to 5 if you're comfortable that this orange line is the same thing as this purple line here. 1 to 5 on that. So everybody's seeing that one good. Okay, point for the room. Okay, let's make the graph a little bigger so it's easier to see. Slide this over. Okay, right here, focus hard on this. Right here, this is x equal, so this is x equals 0 right here. Right in the center of the rectangle is x equal 0.05. Right here is x equal 0.1. Then x equal 0.15 is the center of the rectangle. This is x equal 0.2. I'm hopefully asking an easy question. Raise your hand if you can tell me how wide each rectangle is. Hands up. You can see it. The center of this rectangle is 0.05. Here's x equals 0. Here's x equal 0.1. The center of this rectangle is 0.15. This side here is x equal 0.1. This side is x equal 0.2. So how wide is each rectangle? That's better. Let's go, Bridger. How many agree? 0.2 for Bridger. Okay, so let's write that down. So the width of each rectangle, we're going to do it over here. So we have a rectangle. We're filling the space right here, this purple space. We're filling this purple space with rectangles. Each rectangle's width is 0.1. So the width of every rectangle is 0.1. The width questions. Now I could have chosen a different width. I only chose 0.1 because it's easy to talk about. Raise your hand and answer this. If I choose 0.2 as my width, and I find the area of rectangles that have a width of 0.2, will my approximation for the area be better or worse than if I choose the width of each rectangle to be 0.1? Hands up. Better or worse if I choose 0.1? Two more hands. So I'm choosing the width of each rectangle to be 0.1. If I instead choose the width to be 0.2, which will be more accurate? Brooke? How many agree? 0.2 for Brooke. So the 0.1 is a random choice, just picking something that's easy to talk about. Are we good? Cool. I now know the width of the rectangle. To find the area of the rectangle, I need to know the height of the rectangle. So, for example, the red rectangle that I drew here, this is centered about x equal, we'll say about 0.65 maybe 0.55. That's where the x is located. The width of the rectangle is 0.1. I need to know the height of the rectangle. But because the rectangle is touching the purple curve right here, the rectangle is touching that purple curve, I have the ability to compute this y coordinate right there. Like I can go find this y coordinate. Raise your hand if you know, you all know how to do it. How do I take this x coordinate and compute this y coordinate right there? Hands up. There we go. Let's go, Caitlin.
You substitute it for the x in the equation.
And which equation, Caitlin?
The y equals tangent of 0.55.
Nicely done. So I take the x value and I write tangent of that x value. And we're going to do all our work on the calculator, so we don't really care what that is. We just need to know how to do it. So this is the y coordinate, which means this is the height of the rectangle. So the height of the rectangle is tangent of 0.55. So show me your hand if you knew that before Caitlin said it. 0.2 for Caitlin. We want to talk about anything. Please, Caitlin.
So you're just making up random numbers to like make sure we understand, right?
You are correct. Yeah. And I want to get to the point where I could pretty much make up any number and you'd still know what to do. That will show that you're good on the understanding. So what we've done is we've got this red rectangle, 2 points for Haley. We've got this red rectangle. The red rectangle is centered at x equal 0.55. It has a width of 0.1 because we chose that randomly, and it has a height that is equal to the tangent of 0.55. Questions? So to find the area, I would simply multiply these two together, and that will give me the area of that red rectangle. So then, like Haley said, I can pick another rectangle. Let's draw a blue one. So I put a blue rectangle over, say, here, next to it. Just pretend those are right next to each other because it's a little hard to draw. So the blue rectangle, too fat. So the blue rectangle, you can all do this. If the red rectangle is centered at 0.55 and the rectangles are 0.1 in width, what's the x coordinate of the center of the blue rectangle? Hands up. My drawing's not quite correct, but it's good enough for our conversation. So the red rectangle is centered at 0.55. Just picture a rectangle. The rectangle's width is 0.1. You're going from the center of this one to the center of the adjacent one. So the center of the adjacent one has to be at what x coordinate? Hands, come on.
Does the second one also has to be 0.1?
Yes, so all the rectangles have, no, perfect. We want all the rectangles to have the same width to make it easy. We could do different, but we don't want to. So they all have the same width. So Jacob, where's the blue centered?
0.45.
So blue is centered at 0.45. Show me your hands if you knew that. 0.2 for Jacob. Questions? So Hopefully this is an easy question. Hands up. What's the width of the blue rectangle? Hands up. What's the width of the blue rectangle, Hannah?
0.1.
0.1. 2 for Hannah, 1 if you knew. Okay. Don't need to know the number, just need to know how to find it. So how do we calculate the height of the blue rectangle? Hands up. How do we calculate the height of the blue rectangle? School Porter? Take the tangent of the x-coordinate where the blue rectangle is located. 2 for Porter, 1 if you knew. Questions? Okay, that's the pattern. All we have to do now is apply the pattern to the problem. So every rectangle has the same width. So we can choose a single symbol to represent the width. The symbol we choose is following. Actually, let's go. Let's ask a question first. Hands up, please. What's the x-coordinate on the left side of this blue rectangle? Like, you know where the rectangle is centered. You know how wide the rectangle is. What's the x-coordinate on the left side of the blue rectangle? Brooke?
0.4.
How many knew? 0.2 for Brooke. So the left side is 0.4. Brooke, what's the right side?
0.5.
0.5. Another point for Brooke. And notice, I am taking a difference in x-coordinates. I've got the x-coordinate on one side, subtract the x-coordinate on the other. That is a difference in x-coordinates. That's why the symbol we're going to use is dx. So dx is the symbol that represents the width of each rectangle. Questions? So dx represents the width. Raise your hand if you can. Oh, yeah, please, Jake.
What's the difference between dx and delta x?
Awesome. 2 points for Jacob. In my conversation, I am treating dx as though it is delta x because it's easier to talk about. Dx technically means an infinitesimal difference between x-coordinates, so I'm using dx somewhat inappropriately, like it really is delta x. And I'm just kind of asking you to go with me and realize that, okay, I keep saying dx, what I really mean is dx. In the ideal sense, we would want to go to dx, where the width would be infinitesimal. Does that make sense? Like I said something funny.
Yeah, you said dx 3 times in a row.
Oh, okay.
I think I understand now.
Are you good?
Yeah.
2 points. Anybody else? Okay. Okay, I want you to be able to raise your hand and answer this question with an English sentence. Okay, identifying the width of each rectangle is simple. We're just going to call that width dx, even though, as Jacob said, it's technically delta x. So we're going to call the width of each rectangle dx. Come on. The height of each rectangle is different. The height of each rectangle is not the same, so we can't have a single symbol to represent the height of each rectangle. That won't work. We need a formula for calculating the height of each rectangle. What is the formula that will allow us to calculate the height of each rectangle? Hands up. Carson?
Tangent of x.
So for this purple section, and this is why we split them into 2 sections, and hopefully this will be more clear than it was at the beginning. So for this purple section, it doesn't matter where I draw a rectangle. The height of the rectangle is going to be calculated by using the purple equation, or tangent of x. So the height of the rectangle is always the tangent of whatever x the rectangle is located at. So the height here in the purple space, the height of each rectangle is simply the tangent of the x where the rectangle is located. How many knew that before he said it? 0.2 for Carson. Okay, so give me a 1 to 5 if you're comfortable as to why we are finding the area of the purple first. And once we find the area of the purple, we'll move on to the next space. 1 to 5, show me. So that did help. I just arrived, so he's catching up. Points for the roof. Okay. Questions? Awesome. Okay. So here's what I did. Look. Okay. I promise, if you'll make sense of the spreadsheet, the homework is like the easiest pocket of the year. It's just not hard at all. It's like some work on your calculator, but the mental processing is very simple. So I drew all those rectangles that fit in the purple space. Each rectangle has a center. Up here, these numbers are telling you the center of each rectangle. Questions about any of that, please?
So then, it's a midpoint even sum, right?
Correct. I could have done a left or right. Excel was easier to do a midpoint to make it look right. It didn't really matter which one I chose, so I chose what I could get Excel to do. So, 2 points. So I've got the center of each rectangle, as Jacob said, I'm doing a midpoint Riemann sum. I go find the height of each rectangle by taking this x coordinate right here and plugging it into tangent of x. And then the spreadsheet calculates that value. So these are the heights of the rectangles. Right here. These are the heights of the rectangles. Questions? Awesome. The width of every rectangle I have specified as 0.1. The widths are not changing. Then I calculate the areas here. Like that. By just multiplying.
Won't the widths ever change?
For our arguments, we're going to go with the widths are always the same. We could do more sophisticated things, but we won't for this class. 2 points. Although you will do Riemann sums, you did some in the buff packet where the widths were different. So, ready? Awesome. Okay, so all I did then is I do exactly what integration is. I multiply the height times the width. So I take tangent of x and I multiply by dx. That gives me the area of a single rectangle. And then I add those rectangle areas together to get a total rectangular, a total area right here. Question? Okay, you're not going to do it on a spreadsheet, you're going to do it on the calculator. And on the calculator it's much easier than it is here. So let's talk about how to do that now. So go back to your paper. Okay, first thing, just a reminder, easy questions. Raise your hand, please. Who knows how many points test 4 will be worth? Hands up. Don't say it, just raise your hand. It's not a trick. How many total points will test 4 be worth? Hands up. It's not a trick. We didn't talk about this? I swear we talked about it. So,
I can guess.
raise your hand if you know how many points test 1 was worth. Raise your hand if you know how many points test 2 was worth. Raise your hand if you know they're all the same. It's a really easy scale. It's a scale I like. It's not hard. Y'all think I'm tricking you. I'm not tricking you. It's like, why would you ask stupid questions? I just want you thinking, not listening. So how many points is test 4 going to be worth?
A lot.
Point. How many specific points is test 4 worth?
It's 100, right?
100 points. How many knew that? Point. 2 for Derek. Okay.
Yeah, I mean.
Test 4 is all written. Test 4 is all written. So, for example, if this question were on test 4, it would be worth a total of 9 points out of 100. Okay? Total of 9 points out of 100. There are 3 elements to the problem. Each element is worth 3 points. If you mess up any element, you lose all 3 points. There is no partial. you lose all three. So it is critical that you learn to write what is required. So first requirement, we don't want to use formulas that say y equal, because it leads to mistakes. So we're going to write new versions of those two formulas. We're going to write f of x equals, so put this on your paper. This up here is a good place. F of x equals 2 minus x cubed. And then write g of x equals tangent of x. Questions? Please say it.
Did you put the f of x and g of x in any order?
Good comment, 2 points. That's completely random. Other than, I will always put the f of x in y1 and the g of x in y2 on my calculator to avoid errors. But the choice of whether tangent went with f or g was pure whatever. 2 points for Haley. Anybody else? Awesome. Okay, next thing. You all voted 5 that you were comfortable. We need to focus on this purple space first, because the top of every rectangle in the purple space, the top of every rectangle in the purple space is going to hit the purple equation. So when I'm drawing rectangles here, top of every rectangle is hitting the purple. So I've got to use the purple equation to find the top of every rectangle. Questions? Awesome. That means I've got to go find where the purple region stops, which is right here. So I have to find that point. So you're going to grab your calculator now. And you're all going to put into y1 and y2 what I put into my y1 and y2. Go. So I will be honest, it's kind of annoying to have to get the calculators out, so make sure you remember your calculator next time. All right. If you else not have a calculator, it's kind of annoying to have to get the calculators out while others mean doing it. Walk of shame. Okay. So plug those in. Okay, next thing. We have to get the window right. We have to get the window right. Here's my advice. Look at the problem. See if there's anything in the problem that will easily identify from what x to what x we should graph. Raise your hands. Is there anything in the problem that's showing what x do we start at, what x do we stop at? Hands up. Come on. I would say there's something in the problem that is helpful as far as where do we start, where do we stop. So don't take points for not raising your hand. It's the only way I can tell if you're really with me. So Ty, what do you say?
The f of x equation, the +2.
So I'm not. Your thinking is great, but I'm not following it.
In the equation, it says y equals 2 minus x. So negative x plus 2. Or x cubed plus 2.
2 points for Ty. What I'm trying to figure out is like, where do I start drawing my window? At what x do I start drawing the window, and what x do I stop drawing the window? Let's go to Zane.
Well, you know it goes through 0, 0, so.
Yeah, I would start at x equals 0, so I'd go to my calculator and do that. I'd hit window, and I would go 0. To be honest, I don't see anything obvious as to where I should stop on the right. So my go-to guess after 15 years of working AP problems is 5. I found that has never caused me to make an error. Like, it's not always the right final answer, but it's a good starting point. So I go 5 and then I zoom fit.
What I was saying about the y equals negative x cubed plus 2, that would be like the y max.
Oh, that's fair. You can find the Y maxes, but I personally don't ever worry about that because the calculator does it automatically. Yeah, Zoom Fit, the calculator takes care of the Y max. Raise your hand if you have this on your screen. Show me who has it. Come on. Some people don't have this. Point if you have this. If you don't have this, call me over so I can see what's wrong with your calculator. You're okay. You're using this part. So you've got the right thing set up.
The same as what? My picture looked better before. I know, right? You just, it looked better before I zoomed in. Take me back.
Everybody in the room, please press the mode button. Oh, sorry, go ahead. 1 second. Everybody press mode. Everyone press mode. Mean. Go down the list and find what's different. There we go. Everybody make sure yours matches mine. Just go item by item. Really, the key ones are right here. I like to have my decimal set to 3 because on the written test, if you don't write decimals to 3 places, you lose 3 points. And it's got to be radians. It's got to be radians. Questions? The rest I don't really even, I just take the default. The rest pretty good. Okay, back to the graph. So raise your hand if you have that on your graph. You got it to work now. Show me hand. Point. Okay. Do you need to look at it?
Matches something with my window.
Yeah. Dang it, I don't know the same date. I just want to just guess the time of the it's like today is because I factory reset it like every
February 6th of 2013.
I don't know. Let me guess. I factory reset this about a week ago. It either died or you reset it about a week ago. I actually really like the
Curious.
That was a lot of guess. That was also the compass. That was my favorite unit ever.
Everybody watch this. Hey, watch. If you're taking the AP test and your calculator starts to just, you don't know what's going on, I wouldn't spend any time searching. I would reset and start over. So here's how you reset. Davis is going to do this. The rest of you, I wouldn't reset, but I would follow so you know how. Second, memory. Plus key. Reset, so you hit item 7. All ran, you hit item 1. And this is where I'm not going to go further. You're going to press 2 and it will clear everything. Okay? And now you've got to go back to your mode and make sure, I think the only thing you have to change is the float.
Yep.
It should be in radians. I think you're good otherwise. Okay. So now type in your y equal and see if it works. Check Twi'lets, sorry.
These were some actual questions in the test, and this is not like it's hang on. You have the turn on.
I got full points on this. Yes. I got some notes on my test, like those are some heck of a parallel lines. So I'm like, yeah, I need it. Yeah, you just
Mine- that one was already done either, so.
It's okay.
Jordan said that's my favorite match. Okay.
No.
Don't do that. Don't say that. Behind rugby. It was so. It was like beta rugby. I didn't like it. Read it.
What else can you look?
Come on. About Rachel Malfoy driving the teacher.
Okay. Raise your hand, please. Raise your hand. What you have to do is you gotta look at that picture and look at the picture on the paper, and you have to make an educated guess as to whether you should make the window show, like, look at the board. Like, are you trying to, like, somehow make all of this mess, I'm giving a pretty big hint here, make all of this mess somehow magically look like that by getting bigger? Hint, hint, that's the wrong way to go. Or is it that we're trying to see something way over here, it's just it's not enlarged enough. It's like we've expanded out too far. That's what we're trying to do. The part we're looking at is like here. It's just we've squished it. So we want a smaller X. We don't want to go all the way to 5. In fact, it looks like maybe 1-ish would be a good choice. So I go window, and Jacob says let's put a 2.
Actually, I did 3 and it looked really good, but 2 is.
We'll go 2. Zoom fit again.
But you still not.
Oh, that's okay. It worked better when I just did 2.
Yeah. I need to go a little less. So I'm going to hit on to stop the graphing so I have to wait. So press on, go window again, I'm going to go 1. And then zoom fit.
Wait, what was your Y? This is gonna look nice.
So zoom fit automatically adjusts the Y's. So I don't change the Y's, I just do zoom fit. Questions? You raise your hand if you have this on your screen. Show me who has the point. Okay, look. Look here. We're still not quite right. Okay, listen close. Come on. Listen. The blue keeps going like so. You know, down here. That's not what I want. Back there. So the blue keeps going. So I just kind of estimate, let's see, this is 1. So maybe 1 point what? 1.4 sounds good? 1.4. And then zoom fit one more time. Questions? Okay, last thing I noticed is I'm kind of showing more Y space than I'd like. So I really don't want all this space up here. It looks like if I only go to say, well, it looks like 2 is exactly right. That's what Jacob was saying earlier. I'm just going to go to 2.5, give a little buffer. When you change the Y values, don't do zoom fit. One more time. When you change the Y values, do not do zoom fit. Zoom fit automatically adjusts the Y values. So don't use zoom fit if you're changing the Y values. Just hit graph. I went to 2.5 on the upper Y. Now I look pretty good. Questions? Cool. Okay, next thing, I got to find the intersection. So I go second trace, choose 5. I want that curve. It's asking if I want that curve. I say yes. If I want that curve, I say yes. Guess means put the cursor near the intersection. It's close enough. If your calculator does not say intersection, you will lose 3 points on the test, because you'll end up with the wrong answer. Actually, you'll lose 6 points on the test. So you must make sure your calculator says intersection. Anybody need me to look at their calculator? Okay, next rule. This will also cost you multiple points on the test. this is really not .902. It's .902718359 or something, okay? I'm just making up numbers. The point is the calculator is displaying 3 decimals, but it is storing much more. Therefore, when you do your computations, you cannot use .902. You have to use the full string that's stored in your calculator. So you have to store this number somewhere. So you're going to do this. Second quit. Say it out loud, please. Are we storing an X coordinate or a Y coordinate? Say it. Storing an X. So press X. Press store. Press alpha B for Benji. Cool. Questions?
Why did it just be?
Because A stands for area.
B stands for?
B stands for B. Doesn't stand for anything, so it's short term. I just needed something. I need somewhere to put .902. .902 is now in B.
So it just took the X that we had already calculated from the intersection.
Yep,
And we're just going to this
that is correct.
you find your intersection, right?
So now whenever I type letter B, I'm really typing .902516718. That's what's in B, is that big, long decimal value. I stored it in B.
Does that mean you can go to see all of the values that you stored and like get rid of some of them or edit them?
So there's really no need to get rid of them because you just put a new one in when you need it to be different. I don't know a way to see them all. Maybe there is, but you can type B and it'll show you B. But for our class, I don't know that we ever use more than 2. 2 points for Haley. Anybody else? We need to show it again. Okay. So first thing, if it doesn't say intersection, it's not going to work. So it must say intersection. So second trace, 5. The calculator will ask you a question. Is the cursor on the first curve for which you would like to compute the intersection? So I make sure that the cursor is on one of the curves that I'm using. It's usually very automatic. Press enter to say yes. Second curve, that looks good. Yes, just make sure you're close. Now it will say intersection. I can do that as many times as you need, or slower, or faster, whichever you like.
Is there a chance you can do that again?
One more time? No worries. So it says, do you have this right here?
Yeah.
Good. Go second, 2 points for asking. Trace. Good there?
Yeah.
Choose 5. Now it's going to ask you questions. Does it say first curve?
Yeah.
Awesome. So just use the right left here to move the cursor a little bit, just to make sure you're on one of the curves. We are, so we say yes. The cursor should now move to the other curve. Did it move?
Yeah.
Awesome, perfect. So that's the one we want, so we press enter again. Does it now say yes?
Yeah.
Awesome. That just means put the cursor near the intersection.
Okay.
But it doesn't have to be very close. So close enough. Does it now say intersection?
Yeah.
Perfect.
Yeah.
Anybody else? No, it's good work. You just got to keep asking. Okay, look. Now you got to store it. If you don't store it properly, you're going to lose like 6 points on the question. That means on 10 questions, you're going to lose 60 points. Congratulations, you just turned a score of 40 on the test. Okay? So, go second quit. And just remember, are you storing the X or are you storing the Y? Yeah, so you can store either one. Since it's X, we press X. We say put that X, the store key is above on, put that X into letter B.
So just alpha B.
Alpha B.
Oh, and then you can.
Forevermore, when you type alpha B, it is as if you are typing .9021564.328.
And can you just store 25 different
I actually don't know. I've only ever needed to store like 2, so I've never looked it up. I don't know how many locations that has, but I get your point. Anybody else?
we store X into the letter X?
No, because it's already in X, and the calculator is going to use X for other things. So you never want to keep permanent storage in X. Next time you do a computation, the calculator changes that.
What's the point of storing?
The point of storing is, one, it's the rule on the test, and the reason it is a rule is they're trying to teach you to be as accurate as possible. So when I use this number in a subsequent computation, if I'm using the rounded value, I'm not as accurate as if I'm using the stored value. Okay, is that clear? Yeah, that's the reason. And the test rule is if you don't use the stored value, they will take away points. The obvious question is, well, how do they know whether I stored it or not? Your final answer won't come out right. Does that make sense? 2 points. Please.
Can you save the X value for multiple letters if you write a word?
Oh, interesting. I don't know. I'm guessing no. That's interesting. I've never tried that, Haley. I don't know. I don't think so. I think it'll say error if you try to go like something.
You can't do that.
It says no. It says error. Okay, look up. We good? Quiet? Everybody good? Okay, next thing, look. So look. Okay, you have to tell the grader where you stored the value. If you don't tell the grader, again, you'll lose another 3 points. So, put on your paper B equals. And for me, I'd put a little note up here so I don't forget. Right here is x equal 0.902. That's what we found was that x coordinate. Questions? Okay, we need to find this value as well right here. So we're going to go find that x coordinate. So I grab my calculator. I go graph. That is the 0 of the blue function. We say second, trace, choose 0.
Would you want to use the approximate symbol when you say b is a blank equal to 9.2? Would you want to put approximately?
2 points here. Hey, listen, for the test, even though it really is an approximation, they're fine with using equal. It's kind of like an understood thing. When they say approximate, I use approximate. Otherwise, I just use equal.
Okay.
Question. So you got to find the 0. So you got to make sure I'm on the right function. I'm trying to find the 0 of the blue. I don't want to be on the red, so that's good. Left bound, I'm good. Right bound, move over. There we go. Press enter. Come on, enter. Guess, just make sure I'm close. Make sure it says, come on, 0. If it doesn't say 0, you lose points. Question? We need to store that as well. So second quit. It's an x coordinate. I'm going to store that one in C. I'm going to write it down on my paper. C equals 1.260. Always 3 decimals, unless you want to lose 3 points. Questions? You need me to do it again? No worries. So go back to the calculator. Make sure you're on the graph. Go second, trace, 0. Do you have that? Position the cursor, like if I go up, down, it's going to change to the red versus the blue, but I want the blue. Good there? You're going to go left until you're to the left of where the 0 is located. And then you press enter to set that as your left bound. Is that working?
Did you put your X min? I see the
That's how many here?
So I didn't change the graph at all.
You multiply B and C.
Oh,
Take an interval. What? That's my guess. I want to get the original out of this thing. Put a speaker in it. Every time that you press a button, it has like a different beep. Or you got to go to you go into the graph function, you start using your joystick, and you just type it down.
The singing practically is.
This thing has like a computing power.
anybody else need me to look? You're good.
I'm just not sure
So, you
I was zero, I just.
oh, I got you. So you found it. So we gotta get our hand up here. Pull that number over here. Oh, thank you. So this is tricky. There's a certain way to highlight it. You can highlight it so that you can get the hand on it. If it's lightly highlighted, I think it works. That's very sometimes it'll highlight. It seems to be like a very light click or. This is very good. You're good. So type out, bring that one in C. Coming out. Okay, look, back to the paper. Get back here. Okay, so now all we have to do is say to fill the purple space with rectangles right here. To fill the purple space, all I have to do is calculate the height and the width of every rectangle. We already figured out that the height is calculated using the formula tangent of x. Don't write tangent of x, write g of x. It will save mistakes. It will prevent errors. So I'm going to take g of x. That's going to be the height of every rectangle at whatever x I specify. I'm going to multiply that by the width of every rectangle. The width is dx. Questions? So that is the formula for calculating the area of one rectangle at 1x. Derek sees it, right? Yeah, it's the formula for finding the area of one rectangle at 1x. All I have to do now is do it for many x's. So I'm going to integrate. I'm going to start my computation at x equals 0. I'm going to stop my computations at x equal b. That will find this space right here that we've been calling the purple space. It will do it for about 100,000 rectangles. A lot of rectangles. Okay? Questions? So here's how you type that on your calculator. Go to the main screen. Go Math 9. Everybody have that? If you don't have it, talk to me. You got it?
I'm writing down all the code so you everything doesn't know what you're based on keystrokes.
Okay. We go 0. Come on. To B, alpha B. Then we're doing g of x. Remember, g of x is always in y2, so you don't make a mistake. So I go alpha, trace, choose y2. Then I do dx, like that, press enter. 100,000 rectangle.
For g of x, you could put just tan of x, right?
You can, but I would advise against it. When the formulas become more complex, which they will, it's really easy to type it wrong. So best to just use g of x. For sure. So it's math 9. Good there? Did you get the 0 and the b? The one people have a hard time remembering is the y2. That's alpha trace. Then you pick. You got it? Because remember, we put into y2 our g of x formula. You good? Anybody else? You get to work?
I think so. I just.
Yes, you get the altitude. So when you change the cell, it's go
Oh, okay. That's about some number. I think it's where did I go wrong? I got
Well, make me get a nice. Hey, I see you adopted That's what that is. Describing as arrow, direction, and magnitude. Yeah. What are you willing to trade? I want to yield you. Why would I know that? You guys want to see what's okay, I thought
wanting someone to find out why. What am I doing wrong? Is there some trick why do you do this? You see my point, right? I can say, stems messed up the work. This is the last thing that drives me
You want some?
Yeah, dude, I tried.
It's okay.
So this one's blind. This one doesn't have the price.
Here, I can work on it.
Yeah, why not? I like Josh. A lot better.
Like somehow it thinks it's text.
That's what I also bought.
Oh, wait, text.
And then also I was there for a bunch of
See, now it's too dark. So you go control.
This was more what?
That was fantastic.
Once you learn how, please teach me. Hey, nice singing. Okay, raise your hand if you got this to appear properly. Come on. We got .478, show your hands. Point, question. You notice, hey, come on, look, spreadsheet, look, spreadsheet, look. Notice, when I did, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9 rectangles, it's not that bad. I got .475. So 100,000 was better, but not by a lot. Anyway, question? Okay, next one. Okay, we got to find the area of the green space right here. Okay, this is an easy question. I just want to give you points. Raise your hand and tell me. Oh, Josh, question please.
Do you just write .478, or is that like a long number?
Oh, gotcha. Awesome question, 2 points. I don't want you writing anything yet. That was just demonstrating how it works. I want to find the space, I want to find the green area. This is a simple question. I just want you thinking with me. Raise your hand and tell me. What are we going to write that will represent the width of every rectangle in the green space? Hands up. What we're going to write represents the width of the every rectangle within the green space. Benji.
What is that? Squiggly line called?
Oh, not yet. Point for that. What I'm going to write that represents the width of every rectangle in the green space. Come on, hands. Charlie. Well, we are in the spreadsheet. We thought, no, 2 points. Hey, focus on me. Come on. In the spreadsheet, we thought of the width as being 0.1, but we came up with a symbol that represents the width. What's the symbol, Mark?
D of X?
How many knew? Point, 2 for Mark. 2 for Mark. D of X is the width. How do I calculate? Hints. What's the formula? Come on. What's the formula for calculating the height of every rectangle in the green space? Come on. What formula will calculate the height of every rectangle in the green space? Here we look.
D of X times F of X?
So f of x calculates the height. How many do it? Point. F of x times d of x calculates the area of each rectangle at each x. Question. Oh, you're just adjusting. You're good. Buddy? 2 for Tewila. So you're going to write plus. Come on. Bit of a battle keeping you focused today. Okay, look. Please, question. Oh, you're good. So we're going to start at an x coordinate of b. We're going to stop at an x coordinate of c. We're going to calculate the area of many rectangles by taking the height of each rectangle, that's f of x, and multiplying by the width of each rectangle. And back to Cougar's question, because the question says find the area, they're comfortable with me writing equal, even though it is still an approximation. Kind of like we often will write pi equals 3.14. It's like, to be fair, in most math, we have to write approximate all the time, because we're often approximating. Is that fair? Yes. Please. Just follow my pattern. I think it's safest. So, Naomi, 2 points. If they say approximate, I'm going to write approximate. If they say find, I'm going to write equal. Please, Hannah.
I have
Alpha trace, yes. No worries. Thanks, Spencer. Is that what you needed?
Which y is it for alpha trace, like when you're finding 2 minus x to the third?
So I always put f in y1, g in y2. So Josh, you're going to type this on your calculator. So as I said to Benji, this will have its most accurate computation because you're using all stored values. And then you're going to round your answer to 3 decimals. I believe it's 0.729, is that right?
Yes.
Okay, questions?
Yes, that's.
Hold on.
Oh, you just let that triangle.
No one talk, I can't hear. Silence, come on.
So that we don't mess up like the numbers because it has a long string, do we just type that whole big equation into our calculator?
Yep. Yeah, just type both of them, press enter. That way you get the answer they want you to get without any rounding error. Okay, look at me. We have 7 minutes. I got to show you how to do a few others so you can finish the pink before you come back on Thursday. You have all the tools you need except for one. Look at this idea real quick. It's a really simple idea. I'm going to make up some numbers to make talking easier. If this y coordinate right here happens to be, these are just made up. If this y coordinate is 15, that means this length of the green line is 15. Agreed? Okay. If this y coordinate here happens to be 4, that means the length of this red line is 4. So don't say it out loud, please. Raise your hand and tell me what's the length of this blue line. Hands up. There we go. What's the length of the blue, Brooke? How many knew? Point, 2 for Brooke. Don't talk, we gotta hurry. Don't talk, we gotta hurry. So that concept will work anywhere on a graph, anywhere. If you're trying to find the length of a vertical line, all you have to do is take the y at the top and subtract the y at the bottom. So if I'm trying to find the area of space S, cannot be easier. I need to calculate the y coordinate at the top of every rectangle. That's going to be f of x. I need to subtract from that the y coordinate at the bottom of every rectangle. That's g of x. I need to put that in parentheses because that's the height of one rectangle at 1x. Questions? So what I just wrote on the board will calculate the height of any rectangle in this space right here at any x you tell me. You give me any x inside that space, and I can tell you how high a rectangle will be at that x using the formula I just wrote. Simple, simple idea. Y at the top, subtract y at the bottom. It works on any space, even if the spaces are negative, even if the spaces are positive and negative. It always works. For example, look here. If this is y equal 15, and I had another graph down here like this, and right here was a y value of, say, -6, that means the length of this purple line would be 6. But if I take y at the top, which is 15, and I subtract y at the bottom, which is -6, I accurately discover that the length of the line that runs all the way from here to here is indeed 21. So y at the top minus y at the bottom always. Question? Please.
When you're doing this problem, do you have to show restoring everything? You don't have to say b equals c equals.
Good question. So on the AP test, this question, part A was find area R, Part B was find area S, and so the AP graders consider it all one problem.
Okay.
So you don't have to rewrite anything. All you would do is write what I'm now writing. We start at x equals 0, we stop at x equal b, we put equal, we punch it in the calculator, we write down our answer. Done.
And that's exactly what you would write on
That's
this.
exactly what I would write. This is problem number 2 on the homework. That's all you have to write, other than, has anyone done it? What do you got? What do you got?
1.161.
And that would give you all 9 points for that problem.
Okay.
Questions? Please.
So just really quick in that kind of a list of what are things that we need to make sure we have
Oh, yeah.
written down.
Awesome. Yeah, here's a quick summary. It's really straightforward. Always write f of x equals, always write g of x equals. In quite a few problems, they'll do that for you, so you won't have to. Always label the intersections that you calculate. Always store those values, and that's it. And then just write down what you're computing.
Making sure to draw the.
You don't have to draw any pictures.
No, sorry.
Well, you have to write an integral. Yeah,
The integral.
Gotta write an integral. Cool. Jacob.
Wait, if you're doing more than I can.
Oh, go ahead.
Would this also work for finding S?
Yeah, for sure. Either way. Good job, you guys. I'll check on the pink. I'll expect the pink done on Thursday. So.